components of queen mandibular pheromone and how the quantities of which may affect supersedure. A healthy queen will produce queen mandibular pheromone, QMP, which causes workers to have immature reproductive organs and has been shown to alter dopamine receptors in their brains. When QMP is high, workers are urged to continue serving the queen. However, in the absence of QMP, workers can start to develop mature ovaries and are signaled to raise a new queen to replace the old. In this presentation, the focus will be on 4 specific compounds that make up QMP. Here is the question we are trying to answer. Regarding Apis mellifera, how do changes in molecular composition of queen mandibular pheromone, QMP, influence worker bees to replace an ill-performing queen? The major components of chemical composition of QMP. I'm not going to say their full scientific name because I will just butcher the names. To start off with, we have HVA, acts as a primer by regulating worker behavioral roles and promotes the dispersal of QMP throughout the colony, which promotes cohesion in the caste system as well as prevents supersedure. 9-HDA acts as a primer which enhances the effects of 9-ODA and workers' ovaries development and a releaser to further promote worker retinue behavior. HOB acts as a releaser which further promotes retinue behavior and immediate grooming interaction with the queen. 9-ODA acts as a releaser to attract drones for mating purposes and a primer as an inhibitor of worker ovary development and encourages retinue behavior. I want you to pay close attention to the molecules that act as a primer. On the right side, you will find the molecular structures for these compounds. Please note that 9-ODA and 9-HDA is high quantity in QMP compared to 9-ODA and 9-HDA in worker bees. HOB is mostly behavior influencing, not physical. 9-ODA in high quantities is a sign that a queen produces many eggs. Here's a table that evaluates components and amounts in high-quality queens, which are less likely to be killed by worker bees, and low-quality queens, which are more likely to be killed by worker bees. Notice how the ratio of 9-HDA to 10-HDA is slightly elevated in high-quality queens compared to low-quality queens in 2010, but not as differing in 2012. Also note that in 2010, the amount of 9-ODA between high and low queens barely differs, but is notably different in 2012. The effect of QMP on the worker caste. So, what does all this do? We know kind of what it starts to do, but what are the physical, overall, what is happening? So, it suppresses juvenile hormone in worker bees, which, when elevated, can cause worker ovaries to develop, something that a low-quality queen could be killed for. Suppresses steroids, which play a role in ovary activation, exhibits altered expression of genes involved in reproductive and behavioral traits, ensuring they prioritize colony maintenance over reproduction. Downregulates gene expression involved in ovary development / egg production, such as vitellogenin. Upregulates gene expression involved in non-reproductive functions, such as caregiving and hive maintenance. Influences histone modification and DNA methylation. So I mentioned vitellogenin, so it is a yolk protein precursor that is critical for reproduction. No yolk protein, you're not going to have healthy eggs. For those who don't know, histones help package DNA and organize it. So histone modification can either reduce or promote gene expression. DNA methylation usually acts as a reducer of gene expression. Here in this figure, we see that the average size of a first instar queen, of the retinue for a first instar queen, which are known to be high-quality queens, is higher than third instar queens, which are known to be low-quality queens. Looking at the chemicals in QMP that reflect on worker retinue attraction, perhaps there is lower quantities of 9-ODA in third instar queen QMP, which acts as a primer to promote physiological inhibition in the term of ovary development. So this is basically saying that the first instar larvae, they have more size of workers that are coming to help them and are attracted to them. Differences between first instar and queen and third instar queens. In this figure, there was a significant difference in two-dimensional composite measure between high-quality queens, black squares, and low-quality queens, open circles. High-quality queens raised from younger larvae and low-quality queens raised from older larvae differ in the proportions of the chemical composition in their mandibular glands. This suggests that the high-quality queens may have a better blend and composition of their QMP than low-quality queens. This may be an indication that the quantities of certain chemicals in QMP could lead to supersedure. What can affect the quantities of these chemical compounds? Seasonal stress, such as winter or drought, can significantly reduce 9-ODA. Quantity which prolonged periods of reduction in 9-ODA can lead to reduction in 9-HDA and HOB. This sort of acts as like a positive feedback loop with the chemicals. I guess it would be more of a negative feedback loop actually, because everything's reducing. Oh, that's not happening. Poor nutrition is a major cause of reduction in chemical composition of certain compounds in QMP. Age also plays a role in 9-ODA production. As a queen ages, her ability to produce the compound naturally decreases, which can lead to supersedure. 9-HDA also tends to decrease with a decreasing 9-HDA production. Pesticides such as fluvalinate and QMP have been shown to lower the levels of 9-ODA and 9-HDA. In conclusion, of these four compounds, 9-ODA is in low quality starts a snowball effect, which could lead to queen killing. When 9-ODA is low, egg laying may be reduced and worker juvenile hormone is not inhibited. This can lead to worker overdevelopment, which could cause the rearing of a new queen in response, or as causation in the decline in 9-ODA, the level of HVA and HOB may also decline. This decline may very well signal to a hive a low-quality queen, even if a worker has not yet made a replacement queen. A factor outside of QMP which could contribute are chemical compounds produced from the Duffer's gland or the Turgel glands, may also play a role in the conformation of a low-quality queen. Significance of this, especially regarding maintaining population. In situations where the colony is facing stress or the queen is of low quality, identifying the key compounds in QMP could provide a way for beekeepers to intervene and prevent supersedure, either by supplementing pheromone levels or identifying environmental factors contributing to the queen's failure, such as nutrition or presence of pesticides. In these particular cases, as of now, there's not really a way to supplement pheromones to a hive, but perhaps it could help prolong a queen's life once we do find a way, which until the nutrition of the hive increases or pesticides are reduced, this could, prevent colony collapse, because a failing queen who is killed can totally cause that. So it's just kind of a prevention until a beekeeper can reintroduce a new queen. So that's all. Here are my sources. Thank you.